Okay, I wanted to walk us through the least squares, how to come up with the least squares regression line. So I did send you my personal notes that I took. I call them my crib notes. So when we're doing the least squares line, it's going to start with a data set, similar to what is in the textbook. So I'm actually going to walk through what you would need to do. So here I have a data set of aircraft. I'm just calling them aircraft A, B, and C, number of seats, and a cost element. From these three pieces of data, I can figure out a sum and I can figure out a mean. So there are three steps involved to figuring out the least squares regression. First, you have to find the point of averages. So we're going to find the average of this column and the average of this column. This will be X bar, this will be Y bar. Then we're going to use the given equation down here to find the slope B1. And then once we know a point XY and the slope, just like in point slope form, we'll be able to find the y-intercept. So a few things to make note of. When you find the least squares regression line, the least squares regression line minimizes the sum of the squared errors. Or in other words, if you were to plot the line and found the error between the line and any of these points, this line would give you the minimum error. So here we go. I found the mean of this column, which is 100. Find the mean of this column, which is this number here, 1966.6 repeating. So that's our point of averages. Now things get definitely more complicated when we're trying to find B1, because B1 is the sum of these x's, each x minus your x bar times each y minus y bar. So we're going to take this x minus x bar and this y minus y bar, multiply them together, and then add it to this one minus x bar and this one minus y bar added together, and so on. So I've set up a table below. So here's my x's. Here's my calculation for each x minus x bar. Here's my y's from above, and here are my calculations for y minus y bar. So then I'm going to need to find the numerator in our calculation. I will need to take this times this and plus this times this, which is this, and then this times this. And when I sum all that together, I get 80,000. So that's this numerator. In the denominator, it's the sum of all the x minus x bar squared. So I take this and I square it, this and I square it, this and I square it, and then I have to take the sum, add them up. So if I add up this column, I get 5,000. So B1 is going to be 80,000 over 5,000, and that's 16. On this last page is the third step. I take the x bar, y bar, and the B1 I found from the last step to find the y-intercept using this equation here. So I know this, I know this, and I know this. I can solve for this. So that's what this is showing. I'm plugging this in, solving for my unknown, and that's my B0. That's my intercept. So then I can rewrite my equation with my knowns. So the equation for y is my B0 plus my B1 times x. And that's how I come up with my model.